Let's consider the following electrochemical cell. We have our shorthand cell notation, and we want to find the standard cell potential for this electrochemical cell. We'll have to expand this shorthand notation out into the two half reactions, find those two half reactions in a table and get their standard reduction potentials, and then from that we can find the cell potential. So let's expand this out. So if I look on the left side of the double vertical line, this is the oxidation here. So I have the oxidation on the left side. So my oxidation reaction is going to be iron solid going to iron 2+ aqueous, and that's going to give up 2 electrons. So this is my oxidation. Now on the right side of the two vertical lines I have my reduction. So I start, reading from left to right. So I'm starting with MnO4- in the aqueous phase, and I'm reacting with H+, so this is an acidic solution, and I'm ending up with Mn2+. And since it's an ion, it's going to be in the aqueous phase. And then the platinum here is just serving as an electrode because my product is in the aqueous phase as well as the reactant. So I need a solid electrode to provide a surface for the electrons to be transferred. Okay, so I look up in a table what has these species in it. So I look up in my standard reduction potential table and look for the half reaction that starts out with MnO4- in acidic solution and ends up with Mn2+ as a product. So if I look in my table, so I go and look up in the table for standard half cell potentials, and I find this particular half cell reaction. So it has what I need, MnO4- and H+ as reactants, and the Mn2+ as a product. So this is the balanced half reaction. So the balanced half reactions are given in the table. So now with this I can find the standard half cell potential. So I look up in the table, and the half cell potential for the iron oxidation is 0.45 volts. Now in the table, this is written as a reduction, so it's written backwards. It's written as Fe2+ plus 2 electrons giving iron solid. So in the table, the standard half cell reduction is negative 0.45. But since this is an oxidation, I've written the reaction backwards, and so I changed the sign on the reduction potential from the table. Now I look for this reaction and its standard half cell potential. And this is 1.51 volts. So now E standard for the cell is just equal to E for the oxidation, which is 0.45 volts, plus E for the reduction, 1.51 volts. So this just gives me 1.96 volts for this electrochemical cell. So remember, these are standard states. So this superscript O means all the aqueous concentrations are 1 molar.